Hey guys, College Algebra Math 1513. We're at Northern Oklahoma College. This is Chapter 2, Section 6 in the book. We're going to talk about functions today. We're going to talk about adding, subtracting, multiplying, and dividing functions. And we're going to talk about how to evaluate a composite function, that last one on the bottom there, f of g of x, running a number through one function and then running your answer through another function. All right, here's our instructions. Find f plus g, f minus g, f times g, and f divided by g. And they also want to know the domain of each. They want to know what x's we can put into these functions. All right, for an example, here's two functions, f of x equals x squared minus 25, and g of x equals x minus 5. I've just put the f and the g in red just to show you where the f and g come from that they're talking about. So we're talking about those functions. Let's do the first one. If I say f plus g, so they want to know f plus g. Well, what that means is, what is the f function plus the g function? That's easy enough. Well, the f function is x squared minus 25. So I'm going to replace f of x with x squared minus 25. And then my plus sign comes down. And now they say add the g function to it. Well, the g function is x minus 5. All right, and that's the hard part. Now we just got to kind of clean up the mess and simplify. I'm going to put my x squared first because it has the highest exponent. All right, so I'm done with x squared. And then I look for x's. Here's an x over here, so I have a plus x. Remember, every number has a sign. That x is positive, so it's plus x. And now I'm looking at minus 25 and minus 5. I put those together, I get minus 30. And there's f plus g. All right, let's talk about the domain. I'm just going to put D for domain. The domain is just what x's can you put in there. And I always assume that I can use all real numbers unless I can prove otherwise. So I look at my expression, it's x squared plus x minus 30. I'm thinking, is there any number that I can't put in for x? Is there any number that won't work in there? And I can't think of a single number. I can put negative numbers in there. I can put positive numbers in there. I can put 0 in there. Those are all my real numbers. So I can't think of a single real number that won't work. Therefore, my domain is all real numbers. So a good rule of thumb is assume that it's all real numbers until you can prove that it isn't. All right, let's do f minus g now. So f minus g, all that means is f of x minus g of x. What's my f of x? It's x squared minus 25. So I replace f of x with x squared minus 25. And what's my g of x? X minus 5. So I'm replacing my g of x with x minus 5. Now here's something important to remember. We want to subtract these functions, okay? Now I'm not just subtracting the x, I'm subtracting the 5 as well. I'm subtracting this whole expression. So you want to make sure that you put parentheses around it to show that you're subtracting not just the x, but that whole expression. You're subtracting the whole g of x. This whole function is being subtracted, not just this x up front. Lots of people make that mistake. We're subtracting the whole function. So what we have to do is we have to distribute that negative sign. And a negative times an x is a negative x. Some people like to think of this as a negative 1. You can put a 1 in there if you want to. A negative 1 times x would be negative x, and a negative 1 times negative 5 makes it a positive 5. So when you subtract a function, basically you change their signs. The x was positive, now it's negative. The 5 was negative, now it's positive. That's what subtracting does. It changes signs. My x squared minus 25, nothing happened to it, so I just bring it down. And now clean up your mess. We look for x squareds. There is my x squared. Then we look for x's. There's my minus x. Remember, x is negative. Then I look for numbers. I got a negative 25 and a positive 5. Put them together. I got a minus 20. And again, I can't think of a single number that I cannot put in for x. I think I can put in any negative number and any positive number and 0. So my domain is, again, all real numbers. So you're probably wondering about now, well, when is the domain not all real numbers? So a good rule of thumb, this is just a hint. Okay, a good rule of thumb is look for square roots. If you have a square root, you got to be careful because square roots must be positive. All right, so there are some numbers we can't put in a square root. For example, we can't do the square root of -4. That's not real. Okay, so -4 or negative numbers would not be in our domain. We can take the square root of 0 because the square root of 0 is 0 and that is a real number. So look for square roots. Another thing to look for is denominators. If I have something like this, 1 over x, well, x cannot be 0. So that's another thing you have to watch out for, is x is in the denominator. So just a good rule of thumb, look for square roots, look for denominators, look for anything weird. But an expression like this, x squared minus x minus 20, a simple expression like that, you can put any number in for x. So our domain is all real numbers. All right, how about fg? Well, that just means f times g, which means f of x times g of x. All right, what's f of x? F of x is x squared minus 25, that's this expression right here, times our g of x. What's g of x? That's x minus 5. All right, now notice, I'm not just multiplying the 25 times the x, okay? I'm not just multiplying those two numbers. I'm multiplying the first function times the second function. So I need parentheses around the first function and parentheses around the second function. I don't want to just multiply the 25 times the x. I want to multiply the whole first function times the whole second function. All right, so let's do that. I'm going to do my x squared times my x, that's x cubed. And then my x squared times my -5, that's going to be a negative 5x squared. And then my negative 25 times my x, that's going to be a negative 25x. And then my negative 25 times my -5, that's going to be a positive 125. And I look for like terms. I don't see any like terms I can add together. And guess what? Our domain is all real numbers again. Because we can cube any number, we can square any number, we can put any number in for x. I can't think of a single number that we cannot use. All right, now f over g. So f over g is what they're asking for. Well, that just means f of x divided by g of x. Okay, I'm going to move up here so I have more room. What's f of x? F of x is x squared minus 25 over g of x. What's g of x? It's x minus 5. Now it looks like we're done, but you always, when you have a fraction, you always want to look and see if you can factor something out and maybe do some canceling, all right? Now I notice on top there, the x squared minus 25, I notice that is a difference of squares. So I remember my factoring of patterns, and I remember it's going to be x minus 5, x plus 5, because those 5s need to multiply to give me negative 25, but when I add them they get 0, because we don't have a term in the middle. We have x squared plus 0x minus 25. If you don't remember the special pattern function, think about it like this. I need two numbers that multiply to give me negative 25, but when I add them I get 0. So that would be plus 5 and negative 5. It's quicker if you just remember the special pattern. Okay, so that's on top. On bottom we have x minus 5. I'm just going to go ahead and put it in parentheses so you can see that this factor cancels out that factor. And our final answer is x plus 5. Okay, let's talk about the domain. Now here's a domain we have to worry about, okay? It looks like I can put any number in there for x. And if that was actually our original function, yes, you'd be right. Our domain would be all real numbers. But we have to go back to the original function here. Look at this original function before we simplified it, and look what's on bottom, x minus 5. Remember that our denominator cannot equal 0. So I'm thinking x minus 5, my denominator, cannot equal 0 because we can't divide by 0. So if I solve that, if I just add 5 to both sides, I find out that x cannot equal 5. because if x were 5, then it would be 5 minus 5 on bottom, and I would have a 0. So my domain is not all real numbers. My domain is all real numbers x such that, or as long as, x does not equal 5. And I put my little brackets around it. That's called set notation. Ooh, that's a horrible bracket, but you get the idea. All right, so we can use all number x's. We can use all x's except the number 5, because 5, if we put a 5 in right here, that would be 5 minus 5 equals 0, and I can't divide by 0. So everything works except 5. All right, here's one for you guys to try. There's your f of x, square root of x minus 4. Your g of x is just negative x. You're just going to make whatever you have the opposite sign. And I want you guys to do these 4 functions. So pause the video and see what you can do, and I'll kind of work them out with you here. All right, here's what I got for f plus x. Now think about your domain. What can x not be? All right, remember, we can't take the square root of a negative number. So x minus 4 is under our square root. X minus 4 needs to be 0 or bigger than 0 or positive. Remember, it's okay for x to be 0, for the number under the radical to be 0. So x minus 4 must be greater than or equal to 0. That means x must be greater than or equal to 4. So we say all x's as long as x is greater than or equal to 4. And we work out f minus g and get this. Okay. Domain's the same for the same reason. Now try f times g. All right, there's f times g. We just put that negative x in front, or multiplying by negative x right here. Just move that negative x to the front. That shows multiplication. And our domain is the same for the same reason. Okay, and dividing the functions gives us this. The only thing I'm going to change is I'm going to move that negative sign about halfway up. And so here's our function. All right, now think about the domain. It's a little more complicated. All right, we got some more things to think about. We have that square root on top. That tells us that x minus 4 has to be positive or 0. Now the x on the bottom, remember, we can never divide by 0. That means that x cannot be 0. So how do we put all of that together in a domain? Well, this up here says that x must be greater than or equal to 0. X must be greater than or equal to 4. Well, that actually takes care of that condition. If my numbers have to be greater than 4 to start with, of course 0 won't be included. So actually, our domain stays the same. And it's all numbers x as long as x is greater than or equal to 4. Okay, the last thing I want to show you is what if they actually tell us what x is? What if they tell us the number they want us to run through the functions? For example, here they want us to subtract f minus g. We already know how to do that. But they say, I want you to run 0 through it too. All right, we have a couple ways of doing this. The first way is we could subtract the functions like normal, and when we get to the end, plug 0 in for x. Or we can go ahead and plug 0 in right off the bat and work it out that way. You'll get the same answer either way. I'll show you both ways. It doesn't matter how you do it. So we have f of x minus g of x. Remember to put parentheses around the g of x because you're subtracting the whole function, which makes it minus 2x plus 4 on the end, which becomes x squared minus 5x plus 6. And then we plug our 0 in for x and work it out and get an answer of 6. Now let's try it by plugging 0 in at the beginning. So our substitution would look like this. Remember the parentheses around the g function. You want to make sure you subtract everything in, which simplifies to this, and add your 2 and 4 and you get 6. So either way will give you the right answer. You can do all the x's and plug your 0 in at the end, or you can plug your 0 in at the beginning and work it all out. You'll get the same answer either way. Now you try this one. All right, here's your problem. I want you to multiply f times g, and I want you to replace x with negative 3. And I'll work it out both ways. You can work it out either way. See what you get. All right, here's the first way. If you do all the x's first and then plug in the negative 3 at the end, that's kind of hard. It might be easier to do it the other way. Plug in the negative 3 at the beginning. And here's if you plug the negative 3 in right away and work it out. Simplify each bracket and multiply. That might be a little easier.